So today we're going to be doing a linked list cycle 2. Given the head of a linked list, return the node where the cycle begins. If there is no cycle, return null. So basically, for this question, we are going to be returning the basically the indice of where the cycle begins. So for example, right here, we will be doing position 1 because we start at 0, 1, 2, 3, and this is where the cycle begins, if you can see from right here. So the first thing we're going to do is detect the cycle, right? If there is even a cycle. So we're going to start by visualizing that. We're going to do that by doing the slow fast method, right? To detect if there's a cycle. So for the slow fast method, for every time that fast moves twice, slow will move once. Fast moves twice, slow will move once, right? So when fast reaches null or points to nothing, slow will then stop, and then that either indicates the middle or the rate, like a cycle. Sorry. So a cycle, let's say it points to 2, right? It would look like this. Here and here. Let's start. So 1, 2 here, and then 1, 2. It goes back, and then this would be our cycle right here. Now, the difference between this and cycle 1 is that instead of returning true or false to the cycle, we are printing out the position of where the cycle begins. So first, let's start by coding what we just did, right? Finding if there's a cycle or not. So we have slow, fast, and they're both going to equal the head, right? Because they both start at the head. They will both start right here, right? So while fast and fast.next exist, right, and they're pointing towards something, we will do exactly as we said. Fast equals fast.next, it will move twice, and then slow will move once. In this case, we're going to see if the values, if they equal each other. So if fast and slow eventually meet at each other, that is basically saying that we have found a cycle, right? Like this. Right here is where the cycle will be at, right? So if slow equals fast, well, is fast, right? Doesn't matter. We're going to break this loop, is what we're going to do. We're going to break, and then we're going to then basically do the same thing, but then try to find the position of it. So else, sorry, we're going to have an else because if there's nothing here, right, let's say fast doesn't point to it, we're going to return none. This basically means that this isn't a loop, right? As it says right here, yeah, there's basically no loop for our test case. So to then see if there is, or then to find the indice of where it belongs, we are going to do this. We are going to have let's basically call it another slow. We're going to call it slow 2, right? Slow 2, and then that's going to point to the head, right? And wow, because then this basically still keeps the position of fast, right? Fast will then be right here, and then slow will still be right here. But this time we're moving slow right here. So while slow 2 doesn't equal fast, right? Meaning while they don't stack on each other like this, this basically means that we need to keep on going until eventually they do run into each other, because this is now slow 2, right? And then we will then print out the position of slow 2, because if it does, it basically, because this is still on the position, and once it does, it will return the loop. So slow 2 equals slow 2 dot next, and then fast equals fast dot next. And then from here, we will return slow 2. That will basically return the position of slow 2. So here, here, right? And then here, 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 and then here, right? This is basically what it would look like. One more time, it's going to look like this. Slow is going to start here, and then next is right here. This is basically this column right here, right? This is what I'm visually trying to show you guys. Slow will move up 1, and then fast will move up 1, and then slow will move up, fast, slow, fast, and then slow. Let's see if this works. And yeah, thank you guys for watching.